Okay, sorry about that. I wasn't paying attention to the time, got cut off, talking about symmetry. So basically, to summarize the last bit of the video, you just need to know that there are two axes of symmetry. They won't always be the x-axis and y-axis for an ellipse, but right now, when our center is the origin, then they will be the y-axis and x-axis. But if we change the center off of that, then they're going to become different values here. But again, notice that there's a horizontal axis of symmetry and there is a vertical axis of symmetry. So horizontal axis, vertical axis. Okay, let's go ahead and bump down to the general forms. We have two general forms for an ellipse. So there's nothing too big there is a difference, but it's not huge and it's not hard to decipher between them. The A is the key. A is always the biggest number. So if you have a horizontal axis that is the largest, then your your ellipse will be more wide than it is tall. If your largest number squared is underneath the y squared, then your ellipse, is more tall than it is wide. So that's simply put. So right here, a squared, this square root of a squared is going to be this distance. So if this is a, then this is also a. So the entire length is 2a. So 2a is the length of the major axis. So this entire axis has a length of 2a. Okay. Well, what about our b? So this length from the center to the vertical edge is a length of b, and if you go down, that's also a length of b. So 2b is the length of the minor axis. All right, now let's look at C. C is your foci, remember. So that's somewhere in here, your foci. I'm just making this up. I don't really know exactly where the foci are, but I'm assuming they're somewhere around there. So this length from the center to the focus is length of C. We call that C. That's from the center to a focus. Okay, why am I emphasizing those bits? Because of this information right here. Right, this says that b squared equals a squared minus c squared. Well, if we were to connect, so this is my a here, so a is the longest, so that makes sense. But if you were to rearrange that into like Pythagorean theorem, right, so keep the a squared here, move this c squared to the other side. So we would have a squared equals b squared plus c squared. So a is obviously the hypotenuse of a right triangle. So if we connected my b, which is this length in red, and my c, which is that length in orange, then this is also a length of a right there. Because here's my right angle, so this creates a right triangle. So this length right here is a. And if I do this length right here to this foci, that's also a. So then that tells me that the sum of the focal radii, so this is a focal radii, this is a focal radii, and this sum is always going to be equal to whatever this length of the major axis is. So the major axis is the same as this length of the focal radii. So remember, if I put a point here, we would go from focus, so the sum of those blue parts would equal twice a, this length of the purple. Right, the sum of the blue parts, this part plus this part would equal whatever the sum is across the horizontal axis in this case, across the major axis. Okay, so what's the difference between the first one and the second one? Well, nothing except for that now your largest side, or your largest axis, is underneath the y squared, which means it's more tall than it is wide. So this time your a goes up and down. Right, so this is a, and then you have your foci. So this time your foci are on the y-axis instead of the x-axis. So that's something else I want to emphasize. So up here, your foci are going to be plus or minus c, comma, 0. Right, your foci are on the x-axis. You would go right or left from the origin, up or down, none. On this one, your foci are 0 plus or minus c. We would go from the origin up, not right or left any amount. Your B is still your minor axis, so the horizontal axis happens to be my minor axis, and there we have it. Our length of A, our length of B, and then our foci. Okay, so you can read the bottom part down here. It pretty much says all that stuff, I believe, and let's move on to some practice problems. Okay, I'll take you through a few, then I think you should stop and try some on your own. But notice that your general form here in this box, you should have it equal to 1. So you have x squared divided by some number plus y squared divided by some number equals 1. And we proved that when we did this distance formula, that was going to be the format right here. Right? So that's what we got. X squared divided by some number plus y squared divided by number equals 1. So that's the general form for an ellipse. So if you look at this first example problem on the back, not in general form. So this ellipse is not in general form. We don't have a 1 over here on the right-hand side. So the first thing you have to do is get rid of the 36 so that the right-hand side equals 1. How do you get rid of the 36? Well, you divide each side by 36. So now we simplify. So 9x squared divided by 36 would give me x squared divided by 4 plus y squared divided by 36 equals 1. So as long as you have this 1 over here, no coefficients in front of the x squared or y squared, now we know we have general form. So I'm going to make my x and y axes here. So my x-axis, my y-axis, and I'm going to graph. So how do I graph? Well, I take the square root of the number underneath the x squared, and that's how far out I'm going to go on my x-axis. So this is plus or minus 2. So I go to the right 2, and I go to the left 2. And then I'm going to take the square root of the number underneath the y squared, so that's plus or minus 6, and I'm going to go up 6, and I'm going to go down 6. And then I'm going to do my best to connect those points in a rounded fashion that looks like an ellipse, and there is my ellipse. Done. It's that easy. So go ahead and pause and try the second one on your own. Okay, so did you get an ellipse where you went to the right and left 5 units and up and down 4 units? And so it kind of looks like a circle because there's not a whole lot of difference between 5 and 4 on this graph. So it should look like this. I went right and left 5 units, up and down 4 units after dividing everything by 400, and there's my ellipse. Okay, now how can you find an equation of ellipse given certain information? So remember we had x squared over a squared plus y squared over b squared equals 1. That's what we're trying to do, is fill in my a squared and my b squared. Well, that's really easy. You keep your x squared, you keep your y squared, and you set it equal to 1. If the x-intercepts are positive and negative 1, well, what happened? These are my x-intercepts, right? And what was that? What did we do with those numbers? We would square them to go backwards. So 1 squared is 1. Here, 2 squared, right? Negative 2 squared or 2 squared is 4. So the only thing I had to fill in was a 1 and a 4, and that's my general form for an ellipse. I'm done. That's my equation. This entire thing you must write down. Okay, but what if I give you foci instead of the minor axis and major axis? So here is foci. So we have to go up to this grid on the other side, that said that b squared equaled a squared minus c squared. Right? Remember this right here? B squared equals a squared minus c squared. Okay, but what was b, what was a, what was c? Well, a is my major axis, c is the distance from the center to the foci, and b is my minor axis from the center to the edge of the minor axis. Well, my foci are in the y position. It's plus and minus c. That means that it's 0, comma, plus or minus c, which means my ellipse is going to be more tall than it is wide. So it's going to be tall and skinny. And so that means that my y squared needs to have the a squared underneath it. And if I have a plus or minus 13 as my y-intercepts, well, I'm just going to take 13 and square it, and that's the number that goes under here. So if that's the number that goes under here, and I know that's the major axis because the foci are located on the major axis. So therefore I know that the major axis is underneath the y squared. And remember, the larger axis is the major axis, and that's always my a. So I have a squared minus c squared equals b squared. Well, a squared is 169. What is c squared? Well, hopefully you're saying to yourself, if my foci is here at 0, 5, and 0, negative 5, and my y-intercepts are way up here at 13, this is 5. Negative 5, negative 13, it would be down here. Right? So then what is my c squared? Well, my c squared is 5 squared, which is 25. So I take 169 minus 120, or minus 25, I get 144. So b squared is 144. My last thing I have, which always happens, the x squared over something plus y squared over something equals 1. The only thing we have to do is fill in the blank. This is 144, this is 169. How did I get it? I used this formula from the front. So pause, try to go through the rest of these on your own, and then you can come back and check your answers when you're done. Okay, so hopefully with number 3, you just see there's simple x-coordinates, or sorry, x-intercepts and y-intercepts, the same as number 1. So what do? We just square the x-intercepts. The root 6 squared is 6, that goes underneath x squared. You square the y-intercepts. 2 root 3 times 2 root 3 is 4 times 3, which is 12. That goes under the y squared. And this is my equation of an ellipse. For number 4, okay, this one's like number 2, a little bit more complicated. Even a little bit, it's a little bit different because I gave you the sum of the focal radii instead of the y or x intercepts. So remember, the sum of the focal radii had a little formula that equals twice a. So you can solve for a to get 9, a squared equals 81 then. Okay, so remember, we only need an a squared and a b squared. That's all, the only thing we're going to fill in. Well, I also gave you the foci right here. The foci are plus or minus 6, 0. Remember, the foci are always on the major axis. So that told me that my x has the major axis. So the bigger number has to go under the x squared. Again, how did I know that? Because the foci were in the x position here. They were x, 0, plus or minus 6, 0. So the x-axis is the major axis. Bigger number goes underneath. Then I had to apply my b squared equals a squared minus c squared. I plug that in, I get b squared equal to 45. And remember, the only thing you're putting under here is b squared. So don't waste your time doing this when you're just going to have to go back and square it. So the only thing you needed to find was b squared. So there we have it, a squared and b squared. Okay, I would say go ahead and try graphing these on your own. It's not complicated. It just means if it's less than, you're going to shade the inside of the ellipse. If it's greater than, you're going to shade the outside of the ellipse. So here I get x squared divided by 9 plus y squared divided by 4 is less than 1. I still have to get it in that format where my right-hand side is equal to 1, or in this case, it's less than 1. I make my axes, and then I count out by 3s. I'm going to go by 2s this time. So 1, 2, 3, 1, 2, 3. Again, remember plus and minus square root. I'm going to go up 1, 2. I'm going to go down 1, 2. I'm going to draw the ellipse. Now, because it's exclusive right here, exclusive means you need to have a dotted line. It's not a line, but you still need to have something dotted. Right? So therefore, when you go to connect this over here, it needs to be a dotted line, not a solid line. Be careful. And then your last step, because it is less than, we would shade the inside of the ellipse. Go ahead and pause, try the last one on your own, and then you can compare it with my answer. Okay, so we divide everything by 20. We get x squared divided by 4 plus y squared divided by 5 is greater than or equal to 1. I went out right and left 2 units. I went up and down root 5 units, which is just slightly bigger than 2, so you approximate it on your graph. It's a solid line this time because it has a greater than or equal to symbol. It's greater than or equal to, therefore we shade the outside edge, and there you have it, a beautiful, lovely flower, I guess. So hopefully that is a decent explanation. Good luck doing your homework. Ask me questions, or it's not homework, sorry, we'll do it in class, and you can ask me plenty of questions then. But parabola quiz first, don't forget. See you soon.